Hello everyone, myself Sridhar and I am from Computer Science and Engineering Department. And for the complex engineering project, my topic is about, and for the subject, database management systems. And my topic is about smart watt. Here, the smart watt is the smart energy monitoring and management system. We are going to see what it is. Here we can see the abstract for the project. The SmartWatt is a database, and the SmartWatt is a database-driven system designed to monitor and manage electricity consumption efficiently. Here we can see the system collects energy usage data from you can see the smart meters and stores it in a database for the analysis. It helps users track consumption, generate bills, and optimize energy usage. Here we can see the project emphasizes data design, queries, and efficient data management. You can see here the abstract for the project is here the smart watt is a database-driven system which monitors and manages electricity consumption efficiently. You can see here that the system collects energy usage data and from the smart meters and also stores it in the database analysis. Then we go for introduction for the project. Here we can see the introduction for the project with increasing electricity demand, efficient energy management has become essential. This is most essential nowadays, which is like the electricity demand is like increasing vitally, and then so too efficient energy management has become essential. Traditional systems like real-time monitoring and detailed insights. Yeah. Then the smartboard provides real-time energy tracking, usage analytics, billing automation, and also the data-driven decision making. These all things are like most important. Can see here. Mm, the most important things are like the real-time energy tracking and also the usage analytics, and then billing automation and also the data-driven decision making. Then we can go for the problem statement. Here, our problem statement is like simple, where uh, existing energy systems do not provide a detailed consumptions insight. Lack of real-time monitoring and is inefficient in billing. There is a need of for a system that stores a processed energy data, generates accurate bills, and also provides users reports. Here we can see that already the existing things which mostly focuses on the uh, like we are having the most consumption insights and also like real-time monitoring. So we are going to have a generating accurate bills and also the provide the users reports. Um, it also stores the process energy data. Here the objectives: design a structured database for energy monitoring, stores user and consumption data, generate electricity bills, provide usage analytics, and also optimize energy consumption. Here we can see these are the objectives for the project where we're going to design a structured database for energy monitoring and also the store user and consumption data. And also we're having the generate electricity bills and the provide user analytics and also optimizing the energy consumption. Then we are going to have a system overview. Here the system overview where basically the features user are the user registration, smart meter data storage, and daily monthly usage tracking, and also the automatic bill generation, and also having the reports and analytics. You can see here these are the features. The main features are like user registration. User has to be register for it, and also then the smart meter data storage, which is most important. Then daily and monthly usage tracking. Then having the automatic bill generation and then reports and analytics. Then database design. We are going to design a database, by the way. Here we can see the database. So design where having the entities such as the user, meter, consumption, and the bill. Here we can see the data tables. For the first table, the user table, where the fields are the user ID, name, and address. Where the user ID of integer type and the name of the worker and address of worker. Where you can see here, where you can see here. Okay, which is like a unique user ID and also username and the location. And then here we can see some of the tables such as here there's some such as like a field of meter table and a consumption table and also the bill table. Here the meter in the meter table you are having the meter ID and the user ID. Uh, And also in the consumption table, you're having record ID or meter ID units and also the date where it also the record IDs and the meter references and also user units consumed and having the consumption dates and also bill table where the bill ID or bill ID we're having and the user ID and also total value and amount for the monthly billing month. And then we are having our that's it. Here we can see such that we can having a thing. Wait a second. Here we have the year diagram. We can see here the having the user meter and the consumption and also the bill. We are having this is the year diagram for the database design. Then here some of the SQL queries, so like we are using for this thing, which is like insert into the user values. We are inserting all the details and the number and the user ID, and also then we are going to have the how to retrieve the monthly consumption. Here we can retrieve the monthly consumption through the select sum of units from the consumption such that we can retrieve the things and where month equal to the date and also we can give the date and also then we can generate the bill. Here select user ID and the sum units into 5 as a total bill as 5 is a thing where we are having the price of the each unit and then from consumption we are going to retrieve all this. Then here we are having the algorithm where basically we are using the bill calculation basically depends on this algorithm. We're retrieving consumption data from the user, we are retrieving the consumption data uh, and also then calculating total units, then multiplying by cost per unit, then also storing the result in a like the bill table. Here we can see we retrieve the data from the user, then we calculate the total units, and then for the total units we multiply with the cost, and then we store the result in the table. This is a pseudocode where input and fetch all the units, the total sum equal to sum of units, bill equal to bill into the total into the rate, the store bit, and the display. This is basically the pseudocode. Here are the results: the efficient data storage, accurate billing system, and also real-time monitoring capability. This can be happen only where we're using all these things. Uh, then, what are the advantages for the project? The most advantages are like reduces manual errors. This basically reduces the manual errors. Then also improves the energy awareness and also scalable database design and supports analytics. So here these are the advantages. Okay, the it basically reduces manual errors. That's the most important thing. Then improves the energy awareness and also the scalable database design and also the supports the analytics. Then we are going moving towards the limitations. By the way, every project have a limitations. Here we are having the limitations such as the required smart meters. It is only applicable for the smart meters. Then initial setup cost. It takes some initial setup cost, which depends on the electrical department, which depending on every aspects of the electrical department. And then the data security concerns is as usual. Then we are moving towards the future scope is most important. Integration with the IoT devices is one of the most important thing where we can do, and also having the mobile app for the users, which is the most important thing. The mobile app such that they can uh, monitor their bill daily as they want, as if at any time if they wanted to are like willing to do it. Then AI based energy prediction is the most important. Then smart home automation this can be done and so that's that we can save the electricity and energy. Conclusion: the smart ward demonstrate how database management system can be used to efficiently store the and process and analyze every consumption data. It improves billing accuracy and promotes energy conservation. This is as basic as was as our app saying that it's a smart word. It's demonstrating how the database systems can be used to efficiently store the and process and analyze energy consumption on the data consumption and electricity consumption. It improves billing accuracy and promotes every conservation and energy conservation. Then here are some of the references, such that we can see the Dbms textbook, SQL documentation, and energy management research papers. And this is most important for references for having the app, having this project. And this is all about the project, the smart watt, and using the database management system. Thank you.